So we're going to talk about finding solutions to quadratic equations. In order to understand how to find solutions, you have to know what a solution is. So when we're talking about quadratic equations, the solutions are where your parabola crosses or touches the x-axis. So if you look at the graphs below, each of these yellow lines is on the x-axis. So if you look at this red parabola, you can see that it has two solutions, at -3 and also at 1. So right here at -3, right here at +1, that's where it crosses that x-axis. Our green parabola has one solution right down here because it only touches that x-axis in one place. And this blue parabola has no solutions because it never touches or crosses. Okay, now the solutions are going to be found when it crosses that or touches that x-axis. That's the place where the y value equals 0. So when we go to solve these equations, the very first thing we're going to have to check for is to make sure our equations equal 0. And then finally, the last thing you should know is that solutions are also called roots, zeros, and x-intercepts. So if it says find the solutions, it's asking you to do the same thing as if you were to find the roots. So in a real-world situation, here are a couple of parabolas you might see. And what I want to do is kind of show you, so in this example we've got a dirt bike that's taking this big jump. It definitely makes the shape of a parabola. Your x-axis would be represented, your x-axis would be represented down here. So in this real-world situation, you could find out exactly how long it takes to go from this point back onto the ground. Or the same thing, like Mario here, we can find out from this point to this point exactly how long it would take. So that's just a little bit of how we could use this in the real world. Okay, so in order to find our solutions, there are a couple things we need to remember. The first thing, remember, solutions are where your y value equals 0. And then secondly, remember, factors are what get multiplied together to create a product. The method we're going to be using to solve our equations today is factored form. So we need to have our equations in factored form, and so it's important to remember that factors are what you multiply to get a product. We have two really basic examples here of factors that equal 0. So 7 times x equals 0, or here a times b equals 0. I want you to remember these two things up here because it's important to help you find your answer. So if we know that 7 times x has to equal 0, well that means this x value has to be 0 because anything times 0 is going to equal 0. Now when you look at the problem on the right, we have two different variables. Okay, we know that a times b has to equal 0. What that means is either a could be 0, because then it might be a times whatever value b is, let's say it's 3, which would give us 0, or b has to equal 0, because if b was 0 and a was 3, we would also get it. So in this situation, either a or b has to be 0, and that's what we call our zero product property. If a times b equals 0, then either a is 0 or b is 0, or maybe both of them, but one or the other. And this is going to be helpful to us when we solve our equations in factored form. Because we know when we multiply this times this, it has to equal 0. What that tells us is one of these two factors has to equal 0. So if this was 0, 0 times anything over here would be 0. Or if this factor was 0, then this 0 times anything over here would be 0. So the zero product property is going to help us figure out the solutions to this equation. So the way I'm going to use my zero product property is I'm going to take each factor separately and make it equal to 0. Because I know that this factor might be 0, or this factor over here might be 0. So once I have those written, all I have to do is solve them. So I'm going to use my inverse operations, and I find out that x in this case could be -5, or I'm going to solve this equation, and I'll find out that x could be +2. So if we think about that, if this was +2, so So positive 2 minus 2, that would equal 0. So 0 times anything over here, it's just going to equal 0. Or if my x value was negative 5, oops, hang on. This was negative 5 plus 0, plus 5, that would equal 0. So we can see that as long as one of those two factors is 0, we're going to get an answer of 0. So how do we use this to help us solve equations? There are 4 steps to keep in mind. I want you to use this like a checklist. So step number 1, your equation must equal 0. So the first thing you want to do is look and make sure it says it equals 0. If it does, then you're ready to move on to your next step. If it doesn't, you have to make it equal 0. The second thing is we need an equation that's in factored form. So look at your equation. Is it factored form? If it's set up like this with 2 sets of parentheses, that's factored form. Remember, an equation that looks something like this, I'm just picking numbers here, this is not factored form. That would be standard form. And if you had something that looked like this, that's vertex form. So if you had either of these 2 types of equations, it's not going to work. So you would have to switch it and make it into factored form for this process to work. Okay, so back to our solution here. Because we know we have it equal to 0, and we know it's in factored form, our next step here is we're going to take each factor and make it equal to 0. So I'm going to start here. I'm going to take this factor, x plus 3, and set it equal to 0, because this factor, if it equals 0, makes the whole thing 0. And then it says take each factor. So I'm going to take this factor here and make it equal 0. And then my last step in this is to solve each equation. So I have to solve each one to see what I could possibly have. So this is just solving a basic one-step equation here. So x could be negative 3, or when I solve this one, we see that x could be 4. Now what I want to do is I want to show you what the graph of these parabolas look like. So I have them hidden here. So this is the graph. There it is. This is the graph of this parabola. So one of my solutions here was negative 3. We can see at negative 3 we cross our x-axis. Over here we see that x could be 4. We see another intersection with our x-axis where x is 4. So that's how on a graph you can tell where your solutions are. All right. Now let's do one more problem, the one that's over here on the right. So same thing. Double check. Is it equal to 0? Yes, equal to 0. Is it in factored form? Yep, we have 2 factors there. So next step, set each factor equal to 0. So I'm going to take x plus 2 and make it equal 0. And then I'm going to take 2x minus 1 and make it equal 0. And then I'm just going to solve each of these equations. So x could be negative 2, or this is a 2-step equation here. Don't let it freak you out. You know what to do. So we move the 1, and then we're going to divide by 2. And we see that x could also be 1/2. So it's either negative 2 or 1/2. So let's take a look at that. I have the graph here. So negative 2 is right here. And that could also be positive 1/2. If you look right there, we see positive 1/2. So what you're going to notice is these 4 steps are the same. They're just going to get a little more complex as we go through each problem. Okay, so step 1, check. Is it equal to 0? If you're equal to 0, which we are right here, we're going to move on to step 2. Do you have factored form? Okay, factored form means we have an equation written like this. This is standard form, so we're not in factored form yet, so we have to factor this equation. We factor using these boxes. Now this might take a little bit. If you guys remember how to do this, you can pause the video and move on. But just as a refresher, your x squared term goes in your top left box, your c term goes in the bottom right box. What you're going to do is you're going to look for factors. This has a coefficient of 1 here. We're looking for factors of 24. And remember, those factors of 24 have to add up to this middle term here, which is 10. So you can go through and list all the factors. We've got 1 times 24. We've got 2 times 12. We've got 3 times 8. We've got 4 times 6. And hopefully you remember or you notice 4 times 6 is 24. If I add those together, it also gives me 10. So these 4 and 6 are the factors we're going to use. So we're going to take a 4 and we're going to take a 6, and they go in these boxes, but it's 4x and 10x, 4x and 6x, because what we want to end up with there is 10x. All right, let me get us some room here. So now it's time to do our factoring. We're going to look at our columns here and pull out our GCFs. So we're looking for a GCF between 4x and 24. The biggest number they have in common is a 4. They can both be divided by 4. Over here we have an x squared and a 6x. So the biggest thing they have in common is an x. So this is our first factor. Our first factor is x plus 4. Now we're also going to figure out what factors go here. This time we're not looking for our GCF. We're just looking for what factor do we need with the top to give us this product. So x times x gives us x squared. X times 4 gives us 4x here. Here I have an x. Here I have a 6x, so I know this has to be 6, because 6 times x will give me 6x. So this is my second factor. So my factored form of this equation is going to be x plus 4 times x plus 6. And remember, all that equals 0. So moving on to our next step, we want to make each factor equal 0. So you're going to take your first factor, x plus 4, and make it equal 0. And you're going to take your second factor, x plus 6, and make it equal 0. And now it's time to solve each of these equations. So x could be negative 4, or x could be negative 6. Now, somewhere down here, there was supposed to be a graph. I seem to have lost my graph here. So you're just going to have to trust me on this one. The other ones should have graphs. All right? Okay. So let's look at this problem. Again, going back, make it equal to 0. Is this equal to 0? No. So our first step here is we have to make this side equal to 0. And what we're going to do is we're just going to add 4 on both sides here. So I'm going to get x squared minus 11x plus 18 equals 0. So when it's equal to 0, keep your terms over here in standard form. So your squared term first, x term in the middle. Make sure you have your c term all by itself. Next, is it in factored form? This is not factored, so we got to factor it. So x squared will go here, 18 goes here. We're looking for factors of 18. This is the tricky part. These factors of 18 have to add up to negative 11. So since this is negative, we know when we do our factors, they're going to have to be negative. Okay, to make a positive, we can get a positive times a positive or a negative times a negative. In order for that middle term to add up to be negative, then everything needs to be negative here. So here are our factors of 18 that add up to negative 11 would be these two here. Negative 2 plus negative 9 is going to equal negative 11. So I'm going to stick those in these two boxes. Negative 9, don't forget your x. Over here I've got negative 2x. And now I'm ready to start looking for my GCFs. So let's clear this up. All right. Going this way. Oops, let me change colors. All right, between negative 9 and 18, the greatest common factor is negative 9. This way, greatest common factor is going to be x. All right, now we got to look at our factors over here. X times x will give me x squared. X times negative 9 gives me negative 9x. Over here, I've got negative 9 times negative 2 will give me 18. X times negative 2 gives me negative 2x. So here are our factors. We got to write it in factored form before we can do anything. So I have x minus 9 as one of my factors, and I have x minus 2 as another one of my factors. And remember, this whole thing equals 0. So now we have factored form. We're ready for step 3. Make each factor equal to 0. So x minus 9 equals 0, and x minus 2 equals 0, and then we have to solve it. So add 2 on both sides. So x could be 2, or x could be positive 9. Now this was the graph I was missing before, so if I click over, here, we can see our graph. X could be positive 2, so right here we have positive 2. X could be 9, right there. So those are your 2 solutions. Alrighty, 2 more we're going to do together, okay? So right here, first step, make it equal to 0. This is not equal to 0. We're going to subtract this 8x on both sides. Now, there are no like terms on this left to combine it with, so when we write this, remember, this is where we want to make sure we keep it in standard form. So we're going to have x squared minus 8x plus 16 equals 0. Time for us to factor. Our x squared is going to go here. Our 16 is going to go down here. So I'm looking for factors of 16 that add up to this negative 8. So remember, in order to get a negative middle term and a positive outer term, we're talking about 2 negative factors. So negative 1 times negative 16, negative 2 times negative 8, negative 4 times negative 4. Okay, so negative 4 and negative 4, when I add them together, gives me this positive 8. So those are the 2 factors we're going to use, and we're going to list right in this box here. All right. Now this problem, it has a little bit of a special, different answer here, so I want to draw your attention to it. Let's finish it off and we'll see what's going on here. Okay, so common factors. To go the greatest common factor between negative 4x and negative 16, negative 4, and this would be an x here. I know I'm factoring kind of quickly, but hopefully that's because this is familiar to you. I know for this to be positive, I need this negative and this negative. I always have kids say, well, how do you know which one's negative? In this case, they both have to be negative. Well, what I want you to notice this time, when we write our factors out, I have x minus 4 times x minus 4. Okay? This is going to be a little bit of a different situation. Hopefully you see when we solve each of these, okay, make it equal to 0, and then if we solve it, x could equal 4, or over here, x could also equal 4. We're getting the same answer, okay? Both of these factors are the same, which means both of my solutions are going to be the same. If you think about what that means, hopefully this graph will make sense to you. We only have one solution because both of our solutions here are positive 4. This is a perfect square. Okay, we haven't talked about perfect squares in a while, but when you have a perfect square, it's going to touch your x-axis in only one spot. There's only going to be one solution to a perfect square because both of your factors are exactly the same. Now this last scenario we're going to talk about is totally different. We only did this kind of a problem really quickly, so I want you to look at it carefully, see what you notice. Okay, it is equal to 0, that's good. It must be in factored form. It's not, but it's not even really in standard form because we're missing that last term. Okay, the easiest way to factor one of these problems is not going to be using this box method here. Okay, we're not going to use the box. What we are going to do instead is look for a GCF. Okay, the GCF between x squared and 2x is just x. So this x, greatest common factor, is going to be one of the factors we pull out. Okay, what that means is I'm going to divide each of these terms by that greatest common factor, and then whatever's left over will be my second factor. So x squared divided by x is going to leave me with an x, and then 2x divided by x is going to leave me with a 2. Okay, and all of this would be equal to 0. Now once you have that GCF pulled out, this next part is going to be the same. So you're still going to take both of your factors, this one here, oops, I'm off my pen, give me a sec. So this one here, we're going to make it equal 0, and then we're going to take this factor here and make it equal 0. And then all we have to do is solve. The one on the left doesn't need to be solved because it's already got a solution, just x is 0. So my x-intercept, my solutions here are either 0 or -2. And when we look at our graph, we can see that one of our solutions here is at 0 and one is at -2. So it is okay to get a solution that's 0. It just means that your parabola goes through 0. So take some time, do the on your own problems. There's a separate video that will go over the answers for those on your own problems. So when you're done, make sure you check your work.